Hello everyone, my name is Asar Khan. I'm the NFA engineer in Jinko Solar. Today we are going to make our second video about commissioning of ESS product. In the last video I talked about the commissioning of one of our product which was for the commercial industrial use, which we call Sangiga. Today I'm going to discuss about our another product which we call Santera, which is a DC block. It's a DC container. So in this video I'm going to talk about basic parameters of Santera and about the structure of the container, the communication topology, installation, commissioning, and product operation, and one case study about one of the project that we have recently done. Before I start this video, I need to tell to everybody who is going to use this video that this video is only about the DC block, only about the DC container. We are not talking about the connection with the PCS because there are so many different kind of PCS manufacturing, and each connection with different kind of PCS, different kind of inverters is different. So we cannot make any video to give an overview of each of them. So this is only about the DC connection, about how to connect the container with the PCS. Santera liquid cooling system. There are total 3 categories of Santera product depending on the capacity of each container. The first is 3.44 megawatt hour. This is the first one. I will not go into the detail of each parameters. The cell we are using is 280 ampere hours. The total capacity is 3.4 megawatt hour, and the rated voltage is 1228. Protection grade is IP54. Similarly, our this product is the charging and discharging rate is 0.5 p. The second of our product is 3.72 megawatt hour. The difference, there's no other difference except the system configuration is a bit different from the last one. And this product, this Santera, is for the charging and discharging. Its rate is 1p. It's 1c. The rated voltage is a bit higher. Is 1331.2 volt, and the protection grade is IP55. Then the third one is our this product. This is our latest Santera product, which is a 5 megawatt hour. This is the most latest one, and it's also liquid cooling like all others. The protection grade is IP55, and the cell we are using inside is 314 ampere hours. Okay, so let's move further. This is the structure of Santera, this container, and as you can see, it's just a 20-foot container. All the different Santera products, they are all 20-foot containers, and the only difference is the configuration of the battery or the cells inside. But the overall structure is almost same. Each of them have each of the container have liquid cooling system, the fire extinguishing system, and an integrated cabinet, which is the most important part, and also have some auxiliary other equipments for the detection of the fire and for connection to the external power supplies, external communication. Okay, let's going further. This is one of the rack. I've just taken one picture for one of the rack. As you can see, each of the rack has here is 8 battery packs, and you can see here on the upper side there are smoke detectors, humidity detectors, fire extinguishing system. Then there is a fire extinguishing pipes, as you can see here on this side. This is for the fire extinguishing system. It goes inside the battery packs, and there's a liquid coolant, and each rack has a high voltage box. As you have talked about in the last video, high voltage box is the main connecting point between the battery packs and one rack. It makes one whole rack. Chiller unit, liquid cooling unit. Each of the container has its own liquid unit, and each Santera has its own liquid unit depending on the size. It can be different for different product. It's installed on the back of the side, and if you can see on the front side, you can also see this part. When you see, it's a control part for the liquid cooling unit. As I said before, that a liquid cooling unit can be supplied power from outside, because it needs AC power supply. As you can see in the diagram, for the auxiliary power, for the AC power, we in the integrated cabinet we supply AC power from here. From outside, it can be taken from the PCS, it can be taken from some external source, and then this power supply power to the cooling part, then some air conditioner and some lighting parts and sockets. This all power supplies from this part, and this is the AC part. Firefighting system. Each of the container has its own firefighting system, and it opts automatic fire alarm systems, automatic fire extinguishing system, and a water sprinkler system. It's a three-layer system. First we have the alarm system. If there is a smoke or the high temperature, the alarm will trigger. After the alarm is triggers, if the other sensor they detect there is a fire or something like this, the fire extinguishing system will start working, and it will sprinkle the spray all over inside the container and even inside the battery, depending on the design. And if still need more protection, then the water sprinkling system adopts container level spraying. We can also adopt water sprinkling system. There is a water system here. It can be connected to the external water pipe, and then that will supply power. That will supply water to all of the container, so that the fire can be extinguished. This is the most important part. As I already said before, integrated cabinet is the most important part in each container, because this is the place from where all the connections come from battery to that point to connect together, and from there we take the power and the communication cables and then connect to the next part, to the external part, like PCS or some other equipments. This is how an integrated cabinet looks like. It has a UPS, it has a DC circuit breaker, and on the downside, there is a DC bus bar. If you see from here, this is the connection for the batteries, for the negative and positive. It goes to the DC bus bar, then connected to the DC circuit breaker, and then this is connected to the output part for the DC. Then it's connected to the PCS or inverter. Then on the other side, you can see it's a BAU HMI system, which is the control unit for one container. This is the same thing it's a more close look about the DC bus bar and DC breaker. If you see here, the DC bus bar is behind this, which is already connected when the container left. Most of the connections inside the container has already been done in the factory. The only thing need to be done is connect the AC power supply and the DC cables, and then connect to the PCS. Most of the things already done in the factory. So these are already connected. Only need to be connected to this output DC cables, and then connect to the PCS. And the size of this cable depend on the size of the project, and also on this PCS we are using. So this is the DC part, and this AC input. We need AC power supply from outside or from the inverter side. As I already said before, this is the place where we take it from. We connect it, and then there is a AC power disconnector switch, which is used to connect or disconnect the AC power, and this AC power supplies to all the equipment that I mentioned before. These are other components in the integrated cabinets. If you see this switch, this is for the fire extinguisher system. This is a two-pole switch. Why we use two-pole switch? Because a fire system needs two power supplies. One, it takes from the UPS, and the other we connect from the external power supply in case the customer requires, in case the site design requires, so that if something happened with the UPS, there is no power, the external power can be used, and the fire extinguisher system should keep working all the time, because it's very important for that. And these are some other components. This is for RS485 switch, and there are some other MCBs. Communication topology, as I have talked about before in my last video also. Each battery has a BMS, and then connect to the high voltage box, the second layer of BMS, then to the system control unit, this BAU I just talked about, and that's connected to the external EMS or external communication part. Okay, we go to the installation. This part we also have talked about in the last video. For the commissioning, the most important thing is the people working on the site, they have to be qualified to be working on the site, and they should follow the local regulations. Anybody who's working on the site, when you are going to the site, you have to be qualified enough to hold to do all this work, because it's a high voltage equipments, and any unqualified working, any unprofessional work can cause fatal injuries. These equipments which need to be done, which need to be taken when you're on the site. We have talked about this in the last video also. Installation videos that we can cut installation. We can break installation into three parts: pre-installation, structural installation, and the electrical installation. Pre-installation is you have to check everything about the container, about the any missing components, about the structure of the component, about all the bolts, all the nuts, everything is well connected. Then we go to the structure installation. We have to take the container, lift it, and put it on the side, on the foundation, and then we have to do the electrical connections. So these are three basic steps of the commissioning. Foundation can be different. There are different kinds of foundation. The foundation, there is no one rule to make the foundation. It depends on the site, and when you're making this the foundation, you have to be careful about different conditions. The most important is the condition of the soil, and the second is you have to have there's enough space so that the power cables and the communication cables can be taken from inside the container and can be taken from outside from out the container. So this is one of the picture that I've taken from the site. As you can see, this is the foundation. They make this kind of foundation. It's a little always up from the ground in case there is a flooding, and there is always some passing way for the cables. These are the two most important things, and we have to build some stairs or something like this so that the operation of the container can be done easily. Lifting of the containers. When the container is on the site, we have to take it. Is in the warehouse storage point. We have to take it to the site, and in order to that, you have to use the recommended model for the crane that you're going to use. It should have 80 to 130 tons of capacity, because each of the container is almost 35 to 42 tons. So it's a very heavy, and you have to have the enough capacity for the crane to lift it and take it to the site. These are some of the instructions that you can see we have to follow while lifting. Each of the container have 4 earthing points, and each earthing point should be connected to the ground according to the site ground layout that you have, that the site engineer has designed. It has 4 points, as you can see in this picture also, and you can see in the diagram also. AC cable connections, the same thing again. All the integrated cable are connected to the AC cable from this point, so that AC power can be supplied to the inside the container. Okay, so this is the main basic part. After you have connected the cables inside the container, you have put in the foundation, connect the cables, everything. Now we need to only check that everything is done well. So before officially powering on, check the cables connected to the whole system to make sure that the cables are connected reliably. We have to make sure that the cables are connected reliably. We have to make sure that the positive and negative cables are connected right. It should not be on the wrong poles. That can cause a very big fault. We have to check that the AC power supply that you're connected, it should be in the phase. They should be on the right phase. The phase sequence should not be wrong. And we have to check that all the communication cables are connected reliably, because communication cables are also very important. If there is any mistake on the communication cables, the system will not power up, because the communication is controlling all the switching on and off of the contactors inside the system. This is the before connection. Then after all the electrical cables are connected, the following actions should be took. We have to check all the cables that there is no break in the cables. You have to make sure that the cables are all intact. There is no break inside the cables. It should not be like as somewhere it is broken and the inside power and inside metal is outside. That can be very dangerous. We have to make sure that the seals on the when we connected on our cables, the seals on each point should be well connected, and we have to make sure that when we leave the container, none of the equipment should be left inside the container. External communication cable connections. I always said external communication cables are connected to the BAU unit. As you can see there, this is our BAU unit. All the cables are connected there. But if the cables are more, if there are more communication points, then we also use an RS485 extension, so that if the connections are more, that can be connected here. If not there, if we can connect here in this point. Pre-power checkup. now we are all ready to power up the system. Before we power up the system, we have to check whether all circuit breakers in the electrical compartments and the liquid cooling energy of each rack is disconnected. We have to make sure that the switches in each of the rack, they are disconnected before we power up. And each of the all the circuit breakers, all the switches inside the integrated cabinet, they are all switch off. All the switches for the liquid cooling system, for the fire extinguisher system, they all are closed. Everything is all closed before we power up the system. And then when we go to power up the system, then this is the way that we start. First of all, we close all the circuit breakers, all the DC disconnectors in each high voltage box in each rack. After we connect them, after we close them, we have to go to the integrated cabinet and we have to switch on. We have to close all the circuit breakers, all the MCBs in the integrated cabinet. After we have done all this, there are indications on the cabinet if it is normal or there is a fault. You can see there if it is normal, the green light is on there. Then we can move to the next part, go to the PCS side, go to the inverter side, and then we power up the system from there. And this way the whole system can be powered up. This is a layout from one of our projects that we have recently completed. It has, as you can see in the layout, there are almost 16. There are 16 battery packs, and there are 8 PCS cabinets, and two of the Sunterra, 2 of the battery cabinets are connected to one single PCS container. I can also show you the pictures from this side. This is the site that we have. I just showed the layout about. As you can see here, this here is the PCS. This is the transformer compartment, and on the other side you can see this is one battery container here, one battery container here. This is the transformer, and these are the PCS, and they all are connected together. Then the cables are taken from inside these ducts, and then we take to the external part, to the grid side. This is one of the pictures. You can see all this, and this is all about the commissioning of Sunterra. Thank you.